Hello everyone. Today our lesson is on critical values and the first derivative test. Just want to start out by saying, earlier in the year we studied polynomial and rational function using algebra techniques. And algebra techniques are basically when we used our zeros and multiplicity, and we used end behavior to help us graph the functions. Today we're going to start our unit on curve analysis using calculus. That is, we're going to analyze the behavior of a function by using concepts we've learned in calculus. Later on in the week, we're going to connect the algebra and the calculus together to help us sketch our curves by hand in more detail. But today our focus is just going to be on critical values and the first derivative test and what information it will give us. So let's talk about this. Let's say we have a given curve, and this curve is pictured in front of us. F of x equals x cubed minus 3x plus 2. Now, I just want to mention, this could be any curve f of x. Okay, I'm just specifically using this one because it's easy to see. So if we have this curve and we're looking at it, how can the derivative help us? Well, what does the derivative tell us again? Remember, f prime of x is the slope of the tangent line at any given point on a curve. So if we go back over to our curve for a second, and we drew a tangent line in this section, and then we drew a tangent line in this section, and a tangent line in this section. What's going on there, and how does this help us? Well, what could you say about the slope of this tangent line? The slope of this tangent line is positive, right? In other words, the derivative is positive. In this section, the slope of our tangent line is negative, or the derivative is negative. And the slope of the tangent line is positive, or the derivative is positive. Okay, now more specifically, let's talk about the behavior of the function itself. Well, if we look at the slope of the tangent line and the function, what do you notice about the function? It's moving in the upwards direction, in which case we say the function is increasing. In this section of the curve, my curve is moving in the downwards direction. In other words, decreasing. And if we move to the last piece here, our function is increasing again. Okay. So whenever the slope of the tangent line is positive, or whenever the derivative is a positive value, meaning greater than 0, our function is increasing. And whenever the derivative is a negative value, our function is decreasing. Okay. So we're going to use this today, and we're going to talk about how to describe intervals where a function is increasing and decreasing. We also have to talk about one other thing at this point, and that's going to be what happens when my curve goes from increasing to decreasing, or vice versa. If you notice at each of these points, this is where the slope of the tangent line is 0, or where the derivative is 0. Slope of the tangent line is 0, or in other words, the derivative is 0. Okay, and a pretty important thing is happening here. We have turning points in our graph. Okay, anytime we have a turning point, that means our graph can have either a maximum or a minimum value. We're going to refer to these in calculus as relative maximum values or relative minimum values. And we'll describe them a little bit in more detail in a few minutes. Okay, so basically, in a nutshell, what we're going to be talking about today is how we can use the first derivative to identify intervals where our function may be increasing or decreasing, and any points in the curve where we may have relative maximum or relative minimum values. Those can also be called local max or local mins. So those words are kind of used interchangeably. I just wanted to point that out right now. And also, these relative maximum values and relative minimum values, we're going to describe them as something called critical values in a curve, and we'll get that to that in just 1 second. So just to summarize real quickly what we went through today and how we're going to apply it to a curve, what we're doing here is some teachers call it the first derivative test. So we're going to use the first derivative test anytime we want to kind of deal with any of these things, to help us determine where a function is increasing and decreasing, and to identify any relative maximum or minimum values. Okay, remember, these are going to be turning points in our curve. So the first thing we're going to do is we're going to find what we call critical values. And critical values, we're going to set the derivative equal to 0, because that's where the slope of the tangent line is 0. Or another type of critical value is going to be where f prime of x is undefined and f of x is defined. For today, we're only going to focus on functions that we can find the critical values by setting the derivative equal to 0. And tomorrow we'll extend our kind of what we're doing to include these types of functions. After we find our critical values, we're going to put critical values on a number line and test our intervals. And this is something we've been doing all year long, so it should not be that difficult. And then once we have our intervals tested, anything that has a positive sign on it, that means the function is increasing. Anything that has a negative sign, that means the function is decreasing. And lastly, if we're asked to, we're going to identify any relative extrema. Okay, extrema means we're including. We don't know which one we're looking for, so we're going to identify what we call relative maxes or relative mins. And if it's a relative max, the function will go from increasing or decreasing, or we will see a plus to minus on our number line. And if it's a min, our function goes from decreasing to increasing. In other words, we're looking for where our number line changes from negative to positive. And I want to point out here, when we're getting the value from the number line, that's going to be an x value. Okay, that's going to be our critical value from the number line. If you're asked to actually find the max or min, you're going to want to plug back into the original function to get the y value. Okay, so it's going to be like a two-part question sometimes. Let's work through one complete example, and then I will let you be on your way. All right, so let's say we're talking about this function here. F of x equals x cubed minus 3x plus 2, which was the graph we saw in the picture on the previous page. We want to find the critical values. We want to find the intervals on which the function is increasing or decreasing, and then we want to find any relative maximum or minimum values. So the first thing I want to do, if I want to find the critical values, I need to take f prime of x, which is 3x squared minus 3, and I'm going to take that and set that equal to 0. Now when I solve these, I always try to factor so I don't lose one of my solutions. So I'll start 3x squared minus 1. And then I could divide the 3 away if I want to, or I could leave it out in front. It's no big deal. I'm going to get rid of it for this example. Okay, I just divided through by 3. And now we have x plus 1, x minus 1 equals 0. To finish up this, I would set each factor equal to 0. And the two critical values for this function occur at -1 and at 1. Now these are my critical values. What I'm going to do now is I'm going to take the critical values and I'm going to put them on a number line. And notice I'm going to kind of put it right next to my derivative I used to solve the problem. I'm also going to be real careful about numbering or labeling my number line. I'm testing in this function, not the original. The original gives me points on the curve. This gives me the value of the derivative. My numbers that go on my number line are -1 and 1. Now if I'm going to take a number in this interval, let's say -2, and I take -2 and I plug it into the derivative, I get a negative factor, another negative factor, right? Which means in this interval, my derivative is positive. If I take a number in between -1 and 1, pick 0, nice and easy, plug it in, I get a positive factor and a negative factor. So the derivative is negative in this interval. And if I take a number a little bigger than 1, let's say 2, I get a positive factor, and my derivative, once again, is positive. Well, what does this mean? This means my function is going from increasing to decreasing to increasing, which, if we look at the example on the previous page, it kind of matches what we saw in the original picture. Moving on with our example, if I want to identify the intervals where the function is increasing or decreasing, well, very easy. My function is increasing in this interval, which can be described as the interval from -infinity to -1. My function is also increasing from 1 to infinity. And my function is decreasing over this interval, -1 to 1. Notice I'm not using endpoints. I choose not to because technically, what am I doing here? I'm turning. And even if I'm not turning, I'm not sure what I'm doing. So I just use open interval notation to describe these intervals. And that is perfectly acceptable at this point in time. So now that we've talked about where our functions are increasing or decreasing, that's how we could do that. I just want to point out actually right now, let's say I had two intervals that were negative and negative. That just means my function's not changing. Okay, that's okay. That just means my function is not turning around. It's okay for that to happen. Just because the number is on the number line does not mean you have to have a turning point at that point. And now let's talk about how we can describe any relative maximum or minimum values. Now remember, a maximum is going to be where the derivative goes from positive to negative, and a minimum value is going to occur when the derivative goes from negative to positive. So if I'm looking at my number line here, I'm going to have a maximum value when x equals -1, and I'm going to have a minimum value when x equals 1. But these are the x values where they occur. Sometimes you will be asked to find the y value, okay, because that's technically the maximum value of the function. So to get the y value, you're going to take and you're going to plug -1 into the original function. And doing that, oh, I forgot what my number was here. When you plug in -1, we get 4. So the maximum value is 4. Okay. On your answer key for your homework, I just wrote it as an ordered pair. That is perfectly acceptable at this point in time. But remember, this is where it occurs. This is what it is. Now let's talk about the minimum value. So the minimum value occurs when x equals 1. But if you want the absolute minimum value, meaning the lowest y value on the curve, we're going to plug 1 into our function. And after we do this, we see that that's going to be 0. So the minimum y value is 0. And on your answer key for your homework, I just wrote the answers as ordered pairs. This is where it occurs, meaning the x value. This is what it is, okay, the y value. Okay, and that's it for today. You can go ahead and try your homework on your homework sheet. Thank you. See you tomorrow.